Radiation has existed since the dawn of the universe. It is everywhere, around us in many forms, including light and energy from the sun. We are bombarded by radiation from outer space. It is also present in rocks and in minerals in the Earth's crust. It has been an essential part of the development of life on this planet, but radiation can also harm living tissue. Radioactive materials have been harnessed by man to power our existence, defend ourselves and our allies, and treat our sick. Like many human activities, wastes are generated from our use of radioactive materials. Whilst the radioactivity decays over time, dealing with these wastes is a challenge for our society. Scientists and governments around the world have been working together for decades to develop the best ways of managing radioactive waste. For the most hazardous radioactive waste, most agree this is to bury it deep underground. This is known as geological disposal. Although this sounds simple, disposing of it in this way is a challenge. Scientists and engineers will have to build a system to ensure that most of the radioactivity will remain within the facility in the distant future, allowing releases to only occur at levels that are not harmful. They need to consider the types of waste to be disposed of and how the wastes may behave over very long time periods. There is also the issue of where a geological disposal facility could be sited. In the UK, the government is seeking potential volunteer communities who may be interested in hosting a facility. Radioactive wastes fall into a number of categories. The wastes of relevance to geological disposal include high-level waste, which arises from the reprocessing of used nuclear fuel. This is the most radioactive and generates significant amounts of heat as it decays. And intermediate-level waste, which generates much lower levels of heat. Some of this is so radioactive it cannot be safely handled directly by humans. The measure of the duration of radioactivity is called its half-life. That is, the length of time it takes for the radioactivity to decrease to half its original level. Radioactive half-lives range from less than a second to more than 1 billion years. The longest half-lives are associated with elements such as uranium, which has been present in its natural state since the Earth was formed. Our scientists have to consider the radioactive waste's behaviour for long periods of time into the future. During that time, the face of the Earth may change dramatically with new ice ages or continental drift. Indeed, humankind as we know it may not even exist. It is therefore prudent that radioactive waste is isolated until it no longer poses a significant hazard to living things. Experts worldwide believe that the best way to achieve this is by packaging the waste securely and disposing of it deep underground in a geological disposal facility. They plan a series of engineered and natural barriers which, working together, will prevent the radioactivity escaping to the surface in amounts that could cause harm to life and the environment. This is called the multi-barrier approach, and it is regarded as the key to reliably achieving safety and security. This is how it works. The conditioned waste is trapped in a solid matrix, such as a specially designed glass or cement, to immobilise the radioactivity within the matrix for a suitable period of time. The immobilised waste is contained within engineered packages. The packaged wastes are placed in tunnels or vaults constructed deep underground in the disposal facility. Once all of the waste packages have been disposed of in the facility, all of its tunnels and vaults and access routes will be filled and sealed using appropriate backfill materials. These packages, vaults and closures are the man-made or engineered barriers. A further barrier is provided by nature through the hundreds of meters of rock between the excavated facility and the surface. Over time, it is to be expected that water will enter the vaults and tunnels. This will slowly corrode the containers, and though some radioactive materials may escape, most will be held within the engineered barriers. As time passes and the levels of radioactivity decay, some of the radioactive materials will be released from the engineered barriers, but only to be held by the surrounding rock. Eventually, over even longer periods, some radioactivity could reach the surface. But by the time this happens, the levels of radioactivity will be much less than that of natural radiation. Before permission is given to build a geological disposal facility, appropriate regulators must be satisfied that all the necessary safety and environment requirements will be met. This will be demonstrated via a number of means, including through what is known as a safety case. As we do not currently have a site, our experts have produced a generic safety case, which sets out evidence and reasoning as to why we believe geological disposal will be safe. The generic safety case uses a combination of numerical assessments and qualitative arguments to show how safety can be achieved and evaluated. As our understanding improves, and once a site is selected by the government, our safety case will be tailored to the features of the selected site. The regulators will consult on our safety submissions and obtain views from interested parties before making their decisions on permission for us to proceed. We believe we have found, with the help of our global community, the best possible solution to the radioactive waste problem. We all need to work together to make this happen. We want to know what you think, so let us know by emailing us at rwmdfeedback@nda.gov.uk.